Thanks, Phil. And good morning, everyone. Yeah, so I guess many of you probably know me already because I talk about serverless online a lot. It's a shame I can't see any of you. The lights are so bright. But the funny thing is that every time I talk about serverless, someone always reminds me that there's still servers in serverless, which of course is entirely besides the point. And I think Goiko says it best when he says that the serverless is serverless the same way that Wi-Fi is wireless. Even with Wi-Fi, you still got cables running into your routers before someone can use your Wi-Fi connection. So yeah, serverless is the same way that we still got servers, but those servers are not things that we really care about when we use serverless technologies. And when I talk about serverless, I think about any technology where I don't have to think about managing and patching and provisioning those underlying servers. I don't have to worry about setting up the scaling thresholds and how many instances I want to run. And ideally, I want to have pay-per-use pricing as well, so I only pay for the services when I actually run stuff on them, when people actually use my system. So now that we all know what when I say serverless, what do I mean? The other day, funny thing happened, because I was talking to my new best friend. I was just trying to figure out, what are the things that people are struggling with when it comes to serverless. And for some reason, my new best friend was all sassy. He was like, "You silly human, this is easy, man. What's wrong with you?" And so, of course, we can't rely on AI on this stuff. So I went to social media and asked people, okay, what do you guys think are the hard parts of serverless? And some of you are just super, super helpful. See, quick payoff for the joke. So yeah, my name is Ian. I've been doing stuff on AWS for quite a long time. And since 2018, I've been one of the AWS serverless heroes. Nowadays, I spend some of my time working with the Lumigo team. They are probably the best observability platform, especially if you do a lot of work with serverless. And the main part of my job is working as an independent consultant, where I help other companies adopt serverless and providing training and consulting and things like that. And in my role as a consultant, I see a lot of people struggle with adopting serverless and getting into work within their organization. And I think largely, they are struggling with three things in terms of how to have a faster feedback loop between development and testing, how can you make changes and test it quickly without having to wait for a full deployment cycle, how do you deploy application, and how to make that deployment process easy and efficient, and also how do you organize your accounts and the environment so that you can support parallel development work on the same code base and have different developers all doing their own thing without worrying about who's going to take over there for the next half an hour and whatnot. So going back to my post on the LinkedIn, there's actually a lot of helpful responses, including from Lee, who's around here. Mostly, I think the things that people say about the hard part of serverless is around local development and testing, so that's the first thing I want to talk about today. But before that, I want to just show you my favorite answer from all of that. Apparently, it's easy if you just follow me, so if you haven't done so already, please go and do that. So, testing. Specifically, how can you build a workflow that allows you to have a fast feedback loop between making some changes and then being able to test it straight away? There's a thing that I always hear about serverless is that there's no local development experience. You have to always deploy to the cloud before you can do any testing. And I kind of blame AWS for that because for years, they were pushing this thing about, oh, just test in the cloud. Don't worry about local development instead of meeting customers where they are. And we do want to have that fast feedback loop. It's a good thing to have. So I want to give you a couple of ways you can get that local development experience and still get all the benefits of being able to use the serverless technologies. First option, and I think this is something that James was talking about earlier in his session around serverless versus containers, is using hexagon architectures, which is an architectural pattern on structuring your code such that, and you often see hexagon architectures drawn in a hexagon like this, which are the hexagons, by the way, whereby your core business domain logic is right there in the center. This is the business-specific logic that you have. It doesn't care about AWS. It doesn't care about Lambda, containers, and what have you. And you wrap that business logic inside your application layer. And then you need to get data into your business logic to do stuff, and you need to allow your business logic to talk to the outside world to save data in your database, for example. And that's why you have ports. that allows you to then say, connect your core domain logic to the outside world. For example, I may have an input port that allows me to write an adapter for a Lambda function that is going to then take Lambda's invocation argument for the event and the context object and convert that or adapt that into something that my domain understands, maybe like a command to create a new user in the system. And so tomorrow we may say, OK, we started with doing 10 requests per second, so Lambda's pay-per-use pricing is great. But then now we're doing 10,000 requests per second. We want to go for that cost efficiency at scale, so we want to take that workload and move it to, say, containers, where we're paying for uptime instead of per request, and it's more efficient at our current scale. So to do that, I don't have to change my core domain logic. I just write a new adapter that, again, just adapts a HTTP request from, say, an Express.js application running in a Fargate container, and then convert that to my create user command. So this hexagon architecture pattern allows you to give yourself that portability so that you can easily take the same application and move it across different environments in terms of compute, but also in terms of, say, different databases, and without having to rewrite large parts of the application. And I'm going to talk, and in that case, if your, say, core domain logic needs to create a user and save it into a database, you can have an output port, in this case, to say, write an adapter that's going to save the data into a DynamoDB table. Or for local development, what I can do is I can then create a new adapter that just saves data to a mock or to SQLite. That allows me to more or less keep my application exactly the same as I change different implementations in terms of a database. Because tomorrow, we may realize that our access patterns are now more complex. It doesn't fit DynamoDB anymore. So let's change and use RDS instead. Again, I just have to change the adapter and add a new adapter and figure out how to port the existing data from DynamoDB to RDS, but I don't have to touch my core domain logic. So hexagon architectures is a really good way to structure your code so that you get that code level modularity and also that local development experience as well. And also, it's applicable to just about any language you want to use, and I've done this with multiple languages, and you can also use this with any deployment framework, IAC framework that you want to use as well. It really doesn't matter, because it's about how you structure your code. But, I mentioned earlier, serverless is more than just Lambda. DynamoDB is a serverless database. S3 is a serverless storage service. At the start of the whole serverless thing, we had this saying that we should use Lambda functions to transform data, not to transport data. Because within AWS, there are many, many services that can take data from one place to another just by configuring a few things. You don't have to write and maintain custom code for that. For example, if I've got an API and API gateway, I can ask API gateway to do the authentication and authorization for me by connecting it to a cognitive user pool. And if I have, say, a post endpoint that just want to take the data in the post body and just put into a DynamoDB table, I can ask API gateway to do that for me without having to write a custom Lambda function just to call the AWS SDK. And once the data in the database, I can then have event bridge pipes connect to the DynamoDB stream and just write all the stuff, all the row data changes as events into event bridge bus. And I can also have event bridge pipes notify third-party services, could be CMS, Salesforce, or what have you. But again, just making that HTTP request for me without having to write custom code for all of that. So if that's your serverless architecture, what we often call functionless, then, well, you can't use hexagon architecture because it's about how you structure your code. And when you don't have any custom code, well, you have to find some other way to get that local development experience and get that dev test feedback loop going. And also, when it comes to hexagon architectures, there is quite a bit of upfront investment to create those abstraction layers, those ports and adapters. And oftentimes, I find that it could be, well, too much of an overhead when it comes to projects that I know that doesn't have a lot of complex business domain. So for cases where hexagon architecture is just not a really good fit, there's also other options to get that local development experience when working with Lambda. For example, using local simulation, such as LocalStack. which is an amazing tool compared to, well, at least now, compared to what it was back in 2020 or 2019. If you haven't used local stack for a few years, it's a good time to go check it out because it's much more stable now. There's a lot of new features as well. So for the example I gave you earlier, where it's just a bunch of AWS services, resources, no Lambda function, no custom code, I can still deploy the whole thing, whether it's CloudFormation or CDK app. I can still use local stack's tooling to deploy all of them onto a local running environment with local stack. And besides being able to deploy stuff to your local machine, there's also additional features that they've added since local stack version 3. One of them is called the IAM enforcement, whereby local stack can simulate IAM policies so that, for example, like one thing that's really difficult to debug in AWS is that when there's permission errors between event bridge pipes and your event bus, it's going to fail silently. You're going to have event go into DynamoDB and it's a stream, but then nothing goes into event bridge. And it's really difficult to figure out what the problem is when it comes to IAM. But when it comes to local simulation on event bridge, so on the local stack, you can quickly see a red line in your console that, hey, there's an IAM permission problem between event bridge pipes and your event bus. And of course, if you're using Lambda function to transform the data before it gets sent to the event bus, you can also run that on local stack. You can then put breakpoints in your code so they can get that feedback as your function runs and get that information back into your IDE. So when it comes to using local stack to get that local development experience with serverless, the good thing is that it's got a much better coverage in terms of the different flavors of serverless architectures we have. However, it's still just a simulation. It's not the real thing. You're never going to get 100% accurate. And you may run into edge cases whereby some API you're using is not covered by local stack, or maybe, this is more likely, that the failure behaviors is slightly different from the real thing, where the happy path may be working exactly the same, but where you get some error, the behavior is slightly different. And also, just by having something that allows you to simulate your application locally doesn't mean that you can just forget about testing. Maybe you can deploy a local HTTP endpoint that you can just hit with a local host, but then you're not going to do that every time you make a change, right? You still need to understand and figure out how to write automated tests that allows you to be able to catch regressions as you make changes. And in case you missed it, recently, now AWS has got official integration for local stack through the AWS plugin for VS Code. So if you're using VS Code and you're using local stack, now you've got better tooling to integrate both of them together. Another way to get the local development experience going with serverless, and this is a really good thing for people who are currently, say, building web applications running on servers and EC2s and want to move to serverless, is what we call a Lambda lift. A Lambda lift is basically when you run a web app inside, like Express app or a Flask app, inside a Lambda function. And nowadays, there's some really good support for this in terms of the tooling. So AWS has the AWS Lambda Web Adapter, which more or less allows you to take your existing web app, run it inside a Lambda function, attach the web adapter as a Lambda extension, and it can then convert the HTTP2 web request into Lambda's invocation event. The other way around, it converts the Lambda's invocation event into HTTP request that your web framework understands. And then there's also things that are more language specific. For Node.js, there's Serverless Express. For PHP, there's Breath. And then for Python, there's Zappa, and a few others as well, which I haven't included here. The good thing here is that if you are, say, wanting to port your existing web application into Lambda to get some of that built-in scalability, redundancy, and reduce your attack surface, then this is a really good way to take your existing application and just start moving it into Lambda functions. And because it's just running Express app on your machine, so we know how to write tests for that, and we know how to run those tests by just run F5 on your IDE, and maybe having your code to talk to SQLite instead of RDS, for instance. And because it's just running your Express application, your web applications in the Lambda functions, it also makes your application more portable. Because tomorrow, again, if your business context change and you have to evolve your architecture, then you just take the same web application and put it into a container. But again, serverless is not just about Lambda. And if you've got a more functionless approach to building serverless architectures, then you can't really use this because there's no web application or there's no custom code that you can use this with. And also, when it comes to using, say, the Lambda web adapter, there's also a cold start penalty. For my own testing, I found that by just adding the web adapter, it adds about between 50 and 100 milliseconds to my Lambda cold start. And while for things like APIs, we've got lots of different tooling, including the Lambda web adapter, as well as different web frameworks. For other things like data processing, this is less well supported and less well documented. And also, when it comes to the observability, with API Gateway, we can enable detailed metrics so that we can get metrics for individual methods and endpoints, so we can create those really fine-grained alerts that tells us exactly which endpoint is having a problem with latency or with error rate. We can't do that with, say, greedy API Gateway path going to just one Lambda function now. You can make it up for yourself by creating those custom metrics from your Lambda function by using the Lambda's CloudWatch's embedded metric format, or EMF, from your code. But those are additional work you have to do yourself to make up for the gap. And for lazy people, you can also use the deployment frameworks to get some local development experience, because things like the serverless framework, SAM, and the serverless stack, they all have commands that allows you to invoke or run your serverless, your Lambda functions locally, but also similar API gateway locally as well. Nice thing here is that you don't have to do anything. The framework is doing all the hard work for you, so you can just, just keep doing what you're doing and then be able to invoke your function locally. But then what you get is also very much specific to that framework. And if you use a different framework, say you have to use Terraform for at work, then you're kind of stuck. Suddenly, you lose all of this nice tooling that you get from other framework. And again, this whole all this nice tooling is just about invoking your code. You're running Lambda functions locally and invoking it and getting that breakpoint information back into IDE. It doesn't help you when you don't have Lambda functions. And it's also not a replacement for having proper automated tests that you can run on every change, because you're not going to go and run SST dev and run every single endpoint yourself every time you make a change, right? So you still need to figure out how to do that. Recently, AWS also made this available directly through the AWS plugin for VS Code. Again, if you use VS Code, then you can also do this nowadays without having to rely on, say, SST or Server Framework or SAM as well, which is very nice. So in terms of actually writing tests for your code that's running in Lambda functions, I like to write what I call remote code tests, whereby I execute my code locally, but have it talk to remote AWS resources, hence the name remote code. And the reason why I prefer this approach for writing tests is because when it comes to local tests, often talking to mocks and stubs, is that, yes, they give you a really fast feedback loop. Every time you make a code change, you can be running those tests in the background using VS Code plugins. But then they're also very prone to having false positives. I can't tell you how many times I've had code bases where all the tests are green, but then we are mocking out all the calls to AWS services. And if you're doing, say, a DynamoDB query, your query is just a string. So your compiler or what have you is not going to tell you you've got a syntax error. And your test is going to be green, but then the first time you run it in the real AWS environment, it's going to blow up because DynamoDB is going to be like, nah, that's not the right syntax. So local testing is going to give you a really fast feedback loop, but if it tells you the wrong thing, learning the wrong thing faster is not how we get to working system faster, right? We are going fast, but just in the wrong direction. And testing the cloud, on the other hand, well, it's kind of slow, because even though I make a small code change, maybe adding a comma, I have to wait 5 minutes, whatever, for the full deployment cycle to go through before I can do any testing against what's been deployed in AWS. So if we just take both and kind of just merge them together and just run your code locally, but having them talk to the real AWS services instead of mocks, then you get remote code testing, whereby you still get a lot of the value of local testing in terms of having that fast feedback loop and being able to just make a code change, run your test, and figure out if there's a problem, if your code is working. But your tests are much more realistic because they're talking to the real DynamoDB tables. And if you've got problems with those requests you're making to AWS services, then you're going to find out very quickly as part of your testing. And this approach works across any language, and I've done this with JavaScript, Python, and Java as well. But again, I just keep stressing this, that it's not just Lambda. Serverless is more than just Lambda. And if you don't have any custom code, you can't do this either. So you still have to figure out how can I test my application when it's just API, well, different AWS services connected to talk to each other. And the downside of this remote code testing is that before I can test my code changes, I do need to have those DynamoDB tables and other things like that within AWS and deploy somewhere. So you do have to initially create those environments, but also if you've got multiple people working on different code changes, maybe they need to make different changes to the same DynamoDB tables, for instance, to add different indexes. Then, OK, how do I do those environments, make sure that everyone can work on their own thing separately? Luckily, that problem can be easily solved by using ephemeral environments, and I'm going to talk more about that later. But ephemeral environments is probably one of the more powerful practices that has co-evolved with serverless. But for now, I just want to let you know that there's plenty of different ways to get local development experience when it comes to working with Lambda and serverless. And of course, you can mix and match those different things as well. For example, maybe you want to build your application as a Lambda lift, and you can still use local simulators like LocalStack. So you deploy your Lambda lift onto LocalStack, and then you can run those tests and write them as a remote code tests against what you have deployed on LocalStack. And that's a very useful thing to do, especially if you haven't figured out how to make ephemeral environments work within the real AWS environment you have. So, lots of information, and we're moving fast, I understand. But if you've got any questions, feel free to come ask me afterwards. I want to move on to talk about the deployment. And this is where I like to keep my deployment as simple as possible, which is not, well, I guess nowadays, Lambda is not the simple service it was a couple of years ago. There's a lot of different settings now you can use. You've got Lambda layers, you support container images, you have custom runtimes, you have provision concurrency. There are a lot of different things you can configure, but those are things, I think, features that are specifically targeting use cases where without them, you'll be a blocker. You wouldn't be able to use Lambda. It's not something that everyone should be using all the time. And I think this is where I often find that when I see clients who's got problems with their deployment pipeline where things are difficult, there's a lot of friction, I find that oftentimes it's because they're doing things like using Lambda layer to share the code between different functions instead of using, say, NPM packages. And there's a lot of misunderstanding around how Lambda layers work. And the reasons why I would say don't use Lambda layers is I'll probably give you like 10 different reasons. Number one is that there's no semantic versioning. So you're going to get Lambda layers versions 1, 2, 3, 4, 5, 6, 7. There's no way to communicate to the people that are using your code. Is this a minor change? Is this a bug fix? Is this a breaking change? Do I need to do something in my code when I put it down? And also, if you're using any kind of security scanning tools, well, they don't know that you've got this additional dependency that's sitting inside Lambda layers and are pulled down at runtime as part of your application. And you're also limited to just 5 layers per function as well. And one thing that people always misunderstand about Lambda layers, and I hear this all the time, that, we put stuff into Lambda layer because we're hitting the 250 meg size limit on my Lambda function. Well, unfortunately, the Lambda layers, whatever you have there, still counts towards the 250 meg size limit. So by just putting things into Lambda layer, you're not going to work around that particular limit. And also make it harder for you to exercise your code locally in any kind of testing, whether it's remote code or just having good old unit tests, because some of that is sitting in Lambda layers. And also, they just kind of don't work when it comes to static languages like Java and .NET. It kind of works specifically for Python. For pretty much anything else, I would say Lambda layer doesn't really add any value and actually makes things more difficult. There's more friction in terms of publishing code changes and then put it down on the other side. And if you're doing JavaScript and you want to use bundling to reduce the size of your Lambda function to help improve your code start latency duration, then you also can't do that because part of the code you're going to run at runtime is sitting out there in the AWS in the Lambda layers. So what's that? 8 different reasons why you shouldn't use Lambda layer to share code, but what do you do instead? If you've got multiple functions in the same, say, service, and that's deployed as a single unit, and you want to share the code between those different functions, then just put into a shared folder inside your project. Whether you're using CDK or Server Framework or SAM or Terraform with the server.tf module with Terraform, they all understand, okay, how to package your function and how to tree shake and grab those shared code and put it into the artifact they actually deploy to AWS. But if you've got shared code that's used by different services that have different separate deployments, then you first publish those shared code to a package manager like NPM, and then you put it down on the other side. And now you understand if this change is a minor version update, is this a bug fix, or is it a major breaking change that I have to do something in my code to make sure that I adhere to the new APIs in that package. And also, when it comes to packaging your code, I would say still prefer to use zip files over using container images. There are some really good reasons to use container images to package your code and ship that to Lambda, including ability to have, say, 10 gig in terms of the artifact size, as opposed to just 250 meg. And for functions that are bigger than, I think, about 100 megabytes in size, in the unzipped size, container images also code start faster for both JavaScript and Python as well. But for zip files, you can use managed runtimes, which means in terms of security and attack surface, there are just less things you have to worry about. Your Node.js runtime is going to get automatically patched by AWS all the time, which I understand could be a problem if you are, say, you worry about, say, AWS updating the version of the AWS SDK in the environment and breaking your code. You do have the option to opt out of that and pin the version of the Node.js runtime yourself. But by and large, you should be using the managed runtimes because they're automatically patched and updated by AWS. So in terms of deployment, try to keep things as simple as you possibly can and avoid Lambda layers for sharing code. There's some specific use cases where Lambda layers is good, but for sharing code between different functions, it's not. And also, try to keep things simple and use zip files and managed runtimes instead of using container images. And lastly, around environment, I think you should have at least one AWS account per stage at a minimum. So you have accounts for dev, for test, staging, production, and so on. And for large organizations, you want to go a step further and have one account per team per environment. And maybe some teams have got different workloads. Some are more business critical, or some have higher throughput. Then the business critical workload should also deserve their own set of accounts for dev, test, staging, production. So that way, they can be insulated and protected from whatever else is going on in the other services. And in terms of ephemeral environments, using an example of using a server framework, say I come into the office and I want to work on a new feature, I pick up a ticket. What I can do is I create a new environment, and I'll name it after my feature. And once the environment is created, I've got my DynamoDB tables and queues and topics and what have you. I can start iterating on my code. I can add the new Lambda function that talks to the database table, and I can run those tests, those remote code tests for my code against those remote AWS resources. And once I'm happy that all my tests are passing and my application looks like it's working, I can then create my commit and create a new PR. And once everything's merged, it's all done, I can then just run serverless remove to delete the environment, hence why it's ephemeral. That way, I don't have to worry about whatever other things my teammates are working on, because we all have these short-lived environments that we can develop against ourselves. We have this nice insulation and protection from whatever other things other people are doing. And also, we avoid polluting our shared dev, test, and staging environments with test data. I can't tell you how many times I've seen teams that have this weekly or monthly script they run against their shared environments to clean up all the test data that gets accumulated over time, because everyone runs the test against those environments and is filled with test data. And when you have pay-per-use, You also don't have any overheads in terms of cost. It doesn't matter if you have 1 environment or 100 environments in your account. What matters is how much they're being used, because you're not paying for uptime. That only applies to services that give you pay-per-use. If you have, say, RDS, where you've got a cluster, you're paying for uptime, then you don't want to have 100 different clusters, right? Because then that's going to multiply your cost for RDS. What you can do instead, and I wrote about this in a longer blog post, is just have a shared RDS cluster for each of the accounts, and then you create your databases and tables for individual ephemeral environments. You can also have ephemeral environments inside your CI/CD pipeline, so that when you start the pipeline, you create a new environment, maybe use a SHA from the commit as the environment name. You run your test against that, so you don't pollute your shared environment. And then when the pipeline is done, you delete that ephemeral environment and deploy to the real dev environment, and so on. And we are kept saying environments. I don't mean specifically AWS account. It's not a one-to-one mapping. I've got my main environments for the main account, but then for all my ephemeral environments for development, I put them into my dev account. And an environment is basically a clone or a copy of your service that you're working on, an API or microservice, and you could represent it by a single CloudFormation stack or a CDK app, or maybe some combination of different things, because it may depend on other things like SSM parameters and so on. So you just have to make sure that in terms of the names, you don't clash on names for like Lambda functions and things like that. By and large, if you can avoid it, just don't name your resources and allow CloudFormation to do that for you. So you always add some random suffix. But where you have to name the resource, like event bridge, event bus, then make sure you include the environment name as part of your event bus name, either as a prefix or suffix. And once you have that, you can create many, many environments in the same account. And this works really well with remote code testing, because you need to have something deployed in AWS so that your code can talk to them. So that's how I address the 3 different pillars that people often struggle with when it comes to making serverless work for them from a workflow point of view. And most importantly, I just want you to think about, okay, in terms of local development, how can I get that for when I'm working with serverless? And I hope we've given you something to think about, and if you want to see how some of this plays out in practice, I also have a workshop coming up as well called the Production Ready Serverless. You can go check it out. I think we're going to start in about a week and a half. But otherwise, thank you so much for being here, and I hope you've enjoyed this. If you've got any questions, please come find me afterwards. I'm going to be around for the rest of the day. Otherwise, enjoy the rest of the conference, and see you soon. Bye.
Amazing. Thank you very much, Jan. So you've got about 5 minutes to move to your next session, or, of course, stay here. If for anyone staying here, I'm quite happy to take a question if you are, Jan.
So long I'm not in the way for the next speaker, I'm happy to take a question.
Well, sorry, are you saying you are?
I'm happy so long I'm not in the way for the next speaker.
Cool, right, so yes, if you want to move to another session, feel free to go and do that now. If you want to stay, and if you've got a question for Jan, fire away. Put your hand up, and I will hunt you down. Yeah, back of the room. And just a reminder, the thing that's happening in this room next is David Boyne. Here's the question.
Dave.
Sorry. Hi, yeah, just a quick question on NAMD layers. You mentioned all the disadvantages are not to use them. Could you mention some scenarios where you would use them and how you could use them?
So the question is when I would use Lambda Lift and how I would use that. Is that correct?
Yeah, sorry, that's right, yeah.
Yeah, okay. Yeah, so I think Lambda Lift is a really good pattern. If you, say, for example, taking an existing web application and just want to move it to serverless, and instead of having to rewrite the whole thing, you can use the Lambda web adapter to just take your code as it is and move it into Lambda. So that's a really good way to get straight into serverless and get some of the benefits, some of the runtime benefits in terms of multi-AZ redundancy, in terms of scalability, in terms of security, out of the box without doing much work. You may also want to do this as greenfield projects because, well, our team is familiar with doing web development, but they're not that familiar with Lambda and serverless. So how can I make it easier for them to start doing web development, but also get the benefit of serverless at runtime? So it's about improving the overtime experience while maintaining the runtime benefit. And how I would do it would be mostly with the Lambda Web Adapter. But if you're using Node.js, I actually strongly suggest using the Serverless Express framework instead of the Lambda Web Adapter, because there's some overhead in terms of cold start for using the Lambda Web Adapter, and the Serverless Express is pretty much exactly one-to-one mapping in terms of API compared to Express. So I think that's probably as little work as you need to do when it comes to doing Lambda Live in Node.js. Does that answer your question?
Yeah, no, that's brilliant. Thank you.
Cool, thanks. Thanks. If you've got any